So the name of the course is Design and Analysis of Algorithm. Okay. Uh, Actually, this course, this slide was designed by me in years before. So and it was for 6 semesters. So don't be confused that CSC 603. Actually, the name is 403, CSC 403. Okay. Now there are some reference books that I will say now. Then introduction, what is the algorithm, what is the difference between the algorithm and programs, and what are the models and what are the notations for comparing the algorithm, that we will discuss. But before starting this, I will briefly uh, give you the overview of the course. So first, first we will learn about the different time complexity. Okay, time complexity, notation, etc. We will learn what. Okay, so these will take say maybe 3 4 lectures. uh, Now here, then you will learn what how to compute the worst case, best case, etc. And then also another case is there, amortized time complexity. Amortized time complexity, what do you mean by this, etc. We will learn now. After that, there will be different techniques in algorithm. Means you have been given a problem, then how can you solve the problem? Actually, why you are learning this course? You see, whenever most of you wants demand some projects from your faculty, that please give assign us some projects, we will do, etc. What is the project? That means you will solve some problem. The problem may be very difficult, may be very lengthy, etc., etc. Now the question is that how efficiently you can solve the problem. And also another question arises, is it feasible to solve the problem? If feasible means, can you give design some algorithm that so that you will get the output of the problem in feasible amount of time? Maybe okay after 7 days or 10 days, but we should not wait for the result to get after 3 years, for example. I'm saying we will not prefer that type of algorithm. So there is a question, can you design some solution which you will get the in feasible amount of time, so that the users can wait. Actually my intention is that whether the problems are easy or hard, okay, that we will learn in the later. And also, how can you solve the problems? There are different techniques. Already you know some things. For example, say divide and conquer, you know that quick sort. You have written the quick sort, etc. in data structure class.
Yes, sir.
So divide and conquer is one of the strategy. Okay. Then divide and conquer, what happens? We solve the problem by dividing the entire problem into two parts. Suppose, okay, this is part. Now solve this part, solve this part. Okay, this solution and this solution are merged together. Are merged together. This is called divide and conquer. So this, we are dividing here, and we are conquer means merge. We are merging the solution to get the final output. This is one technique. This is not only the one technique to solve a problem. So there you will also see the another technique is called, here I am writing, pruning. Pruning means what? Pruning means you are deleting something. Suppose this is the solution set. This is the solution set, but you means from where the your solution can be obtained. Now if you know that I will not get the solution from here, I will not get, so you will reject this portion, only you will consider this portion. So this data set will be deleted because I will not get the solution from this portion. This type of technique is called pruning. So you know the pruning technique. Can you tell me example?
Sir, binary search.
Right, binary search. Binary search is one of the example of pruning. Another example is you will learn later. Okay, so you know that if I know that the key element is not present in this hub, then I will throw out that. I will never consider that portion again. So that is called pruning. So this is another technique. So one is say this is the pruning technique, this is the divide and conquer, you know. Similarly, there will be the greedy technique. In greedy technique, what happens that uh, greedy means you are trying to gain some benefit as early as possible. You are greedy. So like that, I mean, suppose you are in Durgapur now, you would like to visit Kolkata. There are so many routes, and you do not know which route will be better, best. Best means in the sense, suppose in terms of time, there are so many routes, and this route will take say this amount of time, this amount of time, but you don't know the fine means all the times means actually say you are suppose here, okay, Durgapur, and you would like to go to Kolkata. Now there are some different next stops means you can go from here, you can go to here or here or here or here. Now these routes go to via other nodes like this, maybe. So you just like a graph, okay. So you are here and you don't know the fine distance between Durgapur and Kolkata. You know only the local information, only the local informations are means known to you, means what is this distance, what is this distance, what is this distance, or how much time say you can it takes to go to the next stop, next part, okay, this. So there will be the algorithm that you may prefer, okay, at present I am getting means I will go to here because this takes small amount of time, this, but you do not know whether this path finally it will take the smallest amount of time or largest amount of time over all paths. But you are greedy, so you are following this strategy that okay, at present it takes small amount of time, okay, I cannot see the entire path, I can see only the local information. Local information I know only the local information. Based on this local information, I am taking this decision. But you please remember this: your decision may be good, may be bad also in for future. Okay, so you do not know. So that types of algorithms are called greedy. That means you are thinking that I will profit more if I follow this path. So you are following that. So that technique is called greedy technique. Now please remember, greedy technique doesn't give always the optimal solution. Okay, sometimes in some problem you will get for a given problem there may be so many greedy idea. You have designed a one greedy idea, your friend may have designed different greedy idea for the same problem. Now one of the greedy idea may be optimal, may give optimal solution, but other may not give optimal solution. Or in case there may not exist any greedy idea, greedy technique to solve that problem so that you will get the optimal solution. So in such case you may have to follow some different techniques. Okay. Next. Next is that say another technique is say dynamic programming. Dynamic programming, what happens that sometimes if you would like to solve using say divide and conquer problem, using divide and conquer technique or greedy technique, it may take huge amount of time, large amount of time. Clear? So in such a case you may see it may happen sometimes that suppose you have see, to solve a large problem, you need to solve a part of it, okay. So this is the large problem, this is the large problem. To solve this entire problem, suppose you need to solve this small size of problems, there are set of sub problems of it, you need to uh, solve all these sub problems. Now if you compute, suppose if you compute all these sub problems so many times, then your time will be very large. Okay, it may happen using divide and conquer. You will see the example I am not saying now, that to solve a problem you are solving a small sub problems so many times, so and the time complexity becomes huge, very large. So what happens in this time? So you may save the time by storing the value of all these sub problems, Okay, in a table, you store all this in a table. Okay, and fetch the data whenever you require again. Means don't recompute it again and again. Okay, so you will use the value of the solutions of the sub problems again and again by fetching it from the table. You will not recompute again and again, so the time will be saved. Okay, I know that space increases, but it's okay. Space is you have been given so many space, no problems nowadays. Enough means RAM size enough, so there is no problem. But time will be saved. Okay, space complexity is another area of the research that I will tell you later. So the dynamic programming, what happens that I will store the results of sub problems at in a table, and whenever it may happen that I need to fetch the data 10 times, so I'll fetch the data 10 times. I will not recompute again and again, so it will save the time. This type of algorithm is called dynamic programming. Okay, and here another important characteristic is that to solve the main problem, this has the criteria should match with the sub problems. There are so many examples that you will learn later, and then uh, you will know about the hard problems that I was saying is NP complete problem. Okay, what do you mean by NP complete? Okay, uh, NP complete problems, NP hard problems, etc. Okay, these problems we'll discuss about these problems, uh, and how they are related also. Means for example, there exists a lot of problems. I have already probably means in last class in discrete mathematics probably I have told, I do not know, I can't remember, that there exist some problems that are very hard. Means if you can crack a problem, then immediately any means your Gmail password will be hacked instantly. Okay, if I means this, there exists a set of problems which are very difficult to solve. Okay, it may take say 1,000 years to solve it. Okay, these problems are really hard problems. But one interesting characteristic is that if anybody can design an algorithm so that he will get the output in feasible amount of time, in polynomial time, then all the problem will be solved immediately. All the problem will be solved immediately. Your password hacking, that means what is the password of the mail or some other document, that is also a difficult problem, but that can be also solved immediately if those problems can be solved. But still now it is unsolvable whether any NP complete problem can be solved in polynomial time or not. Nobody does not know. Okay, there is $1 million offer for this problem, along with others. So this is one of the interesting problems. And then if you then the next part comes that if we know that a problem is very difficult, then you will say, sir, I can't solve it in your industry, that this is very difficult problem, we have no way. Then another way arises that okay, it gives a very hard means it is very hard, so it takes a lot of time. So can you design an algorithm which will not give the optimal solution? Okay, fine, which will not give the optimal solution, but it will be very near of, means the solution provided by it will be near optimal, but the time should be polynomial. Means for example, suppose this is a this is a polygon. Okay, this is a polygon. Okay, now if I would like to illuminate the polygon using bulb. Okay, bulb has 360-degree vision. Okay, or you can say that there are some oil means paintings are there on the walls, and you would like to place some camera so that all the walls are visible by the cameras, and your objective is to place the camera so that the number of camera is minimized. For example, if you place a camera here, then you see in this case that say you see using these, this portion of the polygon is visible. Check. But this camera cannot see this portion. So that means to see this portion, you need another camera maybe here. Okay, so it will see up to this portion, say here. This portion. So still this is not visible. So again you need another camera. Okay, so again you need another camera, and you will place the camera at, say, suppose here. Now here you see I have given you the polygons. Similarly, you may need another camera here, or you may place it here. Now the question is where you will place the camera so that the entire polygon is visible. Now this problem is very hard. This problem is very hard problem. Okay, NP complete problem. Now I am not asking, please remember, I am not asking this problem for a particular problem, but I am asking you that I will give you a polygon of n side, of any shape, n side, and your algorithm should give the solution for each cases. It is not that for a particular polygon you will solve. No, I am not
Sir,
asking.
do we have to use a single camera, sir?
No. So many cameras. That
Okay,
red colors. Yes.
okay, multiple cameras can be used. Okay.
Multiple cameras would be used. Otherwise, it's not possible. Na? It's not possible to see the entire. Now, I am saying that this problem is very difficult. Okay. No, what will be the minimum number of cameras required for any shaped, any n-shaped polygon? N means the number of side is n. It is very difficult till now. NP complete problem. Now you are saying that it is unsolvable, so we can't solve it. So if it is really unsolvable, then I may ask you, okay, I know that you cannot find out minimum number of camera. For example, in this polygon, suppose 4 is the minimum number of camera. Using 4 camera, you can see the entire polygon, but you cannot see. Now my question will be that, can you design any algorithm so that your solution will not be more than the twice of the minimum? Your solution will not be more than twice of the minimum. Means in this case 4, okay, you can give, can you design any algorithm which will give me a solution, say less than 8 cameras? Are you getting what I am saying? For a given polygon, suppose there is a minimum number of camera required to see the entire polygon, that you do not know. But I am asking, okay, you cannot find out the minimum number of cameras, but can you design any algorithm which will give you a solution whose value will not be more than the twice of the minimum, or say thrice of the minimum, or 4 times of the minimum? So these type of algorithms are called near optimal algorithm, or in other words, approximation algorithm. Approximation algorithm. Okay. So how to solve using that using that technique? So that is another chapter. Okay. And similarly, that you type marmits, I do not know actually. The another case is that randomize algorithm. Randomize algorithm. So all these topics you will learn throughout this semesters, and I am saying this is not only important for semester but also for future. I am saying this topic is very important. This course is very important. Those who would like, means you'll see that the Google, etc., they always ask the question from the algorithm. Okay, so in campus interview as well as in your project, etc., this will be very much helpful. This course is very important. Okay, so don't think that this is only the semester it is important for semester purpose. So I request all of you to attend this course. So don't see only the slides, you need to see the books, etc. also. So that I have said that you may attend, the means you must attend, and you may note down the important points. It's not slide doesn't contain everything. Now the books, the most of you means you see this, you know probably this name of this book, Coreman. Thomas Corman, Richardson, Ronald Rivest, and Stein. Okay, so these books you should, you, I think you will have the soft copy also. Probably you may check. So Introduction to Algorithm. This book is very good book. Okay, this is like good book in the sense this is like dictionary. It contains everything. Okay, huge volume. So, and this book is another book is that also the algorithm and design techniques and analysis. So few topics I will uh, take through these from these books. And this is the another book, Orvis Sani. Don't see the algorithms. He has the another books algorithms. Okay, so you just see the sorry, data structure. Don't see the data structure. So he's the author of another book, data structure. So compute, I am asking about the computer algorithm books title. So Sartaj Sani, Sauri Sani, these are the means authors. And here another name of the book is not there, but I am saying if you would like to buy, then according to me, this is the best books, but not for beginners immediately. Eva Tardos and Klinsberg. This is the name of the authors. The I think the title is the algorithm techniques. Most probably, if I am not wrong, the title of the book is algorithm techniques and design. Most probably, okay. You check it. But you, if you give the authors names, then you will get the books, a single books. It is not like that. They are authoring the different algorithm books, algorithm techniques and design maybe, or design techniques like this. Okay, you may buy it. I suggest you, not for semester, I am not saying, but I am saying this will be really helpful for you to keep a book of, means for computer science students, algorithm. Okay, and according to me, Eva Tado's books, this is very good books. You will get a lot of projects also, like so this is very good book, and others you should follow. Now, what is the algorithm? An algorithm is a procedure that consists of a finite set of instructions, which when given an input, if you give an input, okay, from some set of possible inputs, there are so many possible inputs, you are giving just an input and you will get an output. Okay, if such an output exists, if there really exists an output, or you may not get anything if there are no output for that problem. And here these will means that output you will obtain through a systematic execution of the instructions. There will be a finite set of instructions. Okay, these will be executed sequentially. Okay, and actually this is called the definition of the deterministic algorithm. Okay, what do you mean by deterministic? This algorithm is deterministic in the sense the same set of instructions are executed. Same set of instructions are executed when the algorithm is initiated on a particular input more than once. What do you mean by this? Suppose you have been given elements, say 4, 8, 3, say 6, 1, like this, and you have been told to sort this using, say, a bubble sort. Clear? Now you can sort this. So if you take this data and if you use the bubble sort every time, eh, you will check that all the instructions that are executed, okay, on this input will be same every time. Okay, say after suppose 20 steps you will get the output. So all the 20 steps will be exactly same if you do not change this input, if you do not change this input. Okay, but if you change the input, say if you taking some different data, then okay, then the instruction will be different. Okay, so the instructions which are executed will remain same if the input is same. That is called deterministic algorithm. But this is not true for randomized algorithm. Okay. In randomized algorithm, there will relaxation. That means there will be a choice whether 0 or something based on that the instructions will be executed. That is called randomize algorithm. We will now concentrate in our in this course mainly on deterministic algorithm. We are not considering the randomize algorithm. Randomize algorithm will be considered later. Just how to handle the difficult problems. Now you tell me, what is the difference between an algorithm and a program?
Sir, a program has a syntax, sir.
Right?
Sir, a program has a syntax, has a particular
Right.
syntax, but the algorithm can is just the set of instructions that is required.
As a human readable, but it has no proper syntax. Fine. Okay. And why we try to redesign algorithms for a problem even though one's algorithm already exists? Next question.
Sir, to optimize the time
For example,
complexity
why
or the storage complexity, the space complexity, to optimize that.
yes, you see, for example, you know already there exist so many sorting algorithm. Now, why you are designing so many sorting algorithm? Initially, suppose it had so one of the brute force sorting algorithm. Can you tell me? It takes a lot of time.
A linear search.
Oh, you are telling is much better. I
Bubble
am
short.
asking very inefficient. See, hello. Can you tell means which take very large? See, I am saying you. For
So
example,
monkey sort.
you have
It's called
hmm?
monkey sort or something.
I do not
Or
know
pogo
monkey
sort.
sort. This is
Oh,
the
okay.
first time. Sorry, I do not know. But I am saying what you see. Very these are the data. Suppose 2, 8, 1, 3. Just random data I am giving, and you have to sort this. Now tell me in how many ways you can write this sequence? Factorial n.
In fact,
Correct or not?
Yes, sir.
yes, sir.
So, so now tell me one of the those factorials will be the in the sorted order or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
So that means if you can write all possible permutation of the string, then one of them will be in the shortest. So after that you can find out. So this is very inefficient algorithm, but it takes because to find out the permutation it needs factorial n. Okay, factorial n. So automatically you know that is very time. Factorial n means n into n minus 1 into n minus 2 like this up to say 2 into 1 like this. So it is very time complexity very high. Now, after this, say suppose this is done by a class 11 student, then he is learning that n square algorithm that you know, or then n log n, then linear is not possible. Linear is only possible in case of radix sort, where the numbers are not compared. You see, please remember that there are two types of sorting. One is called sorting based on comparison. Comparison means you are checking whether A is greater than B or not. You are doing like this. You see in the all type of sorting algorithm, you check it. But in radix sorts, you are not comparing the two elements. Those who know the radix sort, that is different idea. Okay, so sorting based on comparison, it will take at least n log n time. Anyway, so our objective is to improve the time complexity. What do you mean by time complexity? The running time of an algorithm on a particular input is the number of primitive operations, or steps executed. Okay. The running time of an algorithm on a particular input is the number of primitive operation or steps executed. Now, so it is convenient to define the notion of steps so that it is a machine independent as possible. What do you mean by machine independent? Machine independent means suppose you are saying that I am using Pentium 4 architecture, somebody is saying I am code to do like this. No, it should not be dependent on that. Okay. Actually, the time complexity depends on the input. When the input is very high, you will see the total time becomes very large also. So in that case, the machines are not dependent. Okay. So, and always please remember, if you design, this is very important, if you design any algorithm for any problem, so if you say like that, my algorithm is very good, but please remember, don't take the number of elements input more than 100. If you say like this, then your algorithm is not good. Are you getting what I am saying? That you should you should say in this way, okay, whatever be the input size, you see, my algorithm is very good. It works very fine. Then I can accept. Okay, then I will say you please show me. But if you say like that, please run the algorithm and you will get the output immediately. But please remember, don't take the input size more than 100 or more than 200 element. Please don't take. Then there will be problem. No, so that means the upper bound, the largest value of n, we will consider all the whatever values of the n. So in that way, that means we will compare two algorithm if the worst case is better than the other. So time complexity of an algorithm is denoted by Tn, is denoted by Tn, and it is measured in terms of n. What is n? The input size. Don't think that n means only always the number of element. It may be the width. Suppose if you would like to find out the GCD of two numbers, how many bits are required to store the two numbers, that is also important. So don't think always that the input means the number of elements. No, input means number of elements. It may be the width required to store a number also. Okay. So how many, if I ask you how many bits are required to store a value which is n, how many bits are required?
Sir, repeat the question once more, sir.
How many bits are required to store n? N means an integer whose value is n. How many bits are required?
Log n.
Yes, log to n. Okay. If I am using the binary numbers, you know that using 3 bits we can represent means say 8, like that. What do you mean by space complexity? Space used by an algorithm is the number of memory cells needed to carry out the computational steps are required to solve an instance of the problem. And what do you mean by instance of the problem? Instance means then input that I showed you earlier, that you sort that 4, 1 minus 6 like this. That is an instance of the problem. Sorting is the problem. An instance is a particular input. So the space complexity refers to the how much workspace is required for your algorithm. That means if you are using, suppose for example, you are using a two-dimensional table to solve some problem. Means what is the size of the two-dimensional table? N cross n square. So big of n square will be a space complexity. Now we generally do not bother about the space complexity too much. Why? Because nowadays the machines have a large spaces nowadays. So space is not a factor, but space is a factor. Can you tell me why the space will be a factor? Anybody?
Sir, in case of large inputs, sir.
No, inputs are same. This type of algorithm, but in which environment the space complexity does matter? In sensor network,
When we have
tiny device,
limited
limited memory space is available. For example, in sensor network, suppose there are sensors spread in an environment where the sensors has some computability machines, and they can compute something, but you see they have very small amount of space. So if you would like to apply the sorting algorithm which takes a lot of space, then it is not good. So in that case you have to design in such a way your algorithm will be space efficient. So there is another research work, that space efficient. How can you design the same problems but in space efficient? Space should be efficient. Time may be larger, I know, Obviously, if you would like to take small amount of space, then time will be larger, but you should give some result. And it is always not possible to to have a space efficient algorithm. It's very difficult also sometimes. Now, RAM model, okay, in time complexity and space complexity are uh, measured by RAM model. Mm, it is not random access memory. Okay, so actually it is called random access machine. So if, how can we compare the time complexity algorithm with the others? Okay, so that means, or in other words, how can we study the time complexity of the algorithm if we do not choose a particular machine to measure it? So this, for this we assume there exists a processor. Okay, processor means CPU, but actually it is theoretically. Please remember, it doesn't exist in reality. It is theoretically or virtually. Means we assume, you see, we shall assume a generic one processor, only one CPU is there, and that is called random access machine, a RAM model. Okay, RAM model of computation as our implementation techniques, and that is based on these computer programs. So we will assume there are some characteristics of this machine. This RAM machine is not the RAM of our laptop or say desktop. Please remember, this is not the, these are not the same. We will compute the time complexity of our algorithm. To time measure the time complexity, we need a machine. So we will think that there exists a machines which have only one processor, that is called random access machine. And using this computational model, we'll compare the time complexity of two algorithms or more than one algorithms. We'll compute the time complexity of a particular algorithm. What are the characteristics of the RAM model? So in RAM model, the instructions are executed one after another with no concurrent operations. That means two operations cannot concurrently execute in such a model. This is the one characteristics. Okay. Next, RAM model contains instructions that are commonly found in real computers. Okay. In real computer, what are those? Arithmetic. Arithmetic means add, subtract, multiply, divide, etc. These. Then data movement, load, store, copy. Okay, these are the operations are possible. And control means, you know, that uh, if else, the conditional branch, unconditional branch. Okay, you are calling the function, all this. So these are the called control type statement, data type movement, load, store, copy, and arithmetic. So these are the three categories. And in RAM model, we will assume that all these instructions take constant amount of time. Constant amount of time is big O of 1. That will tell you big O of 1. What is big O? Already I think Jana sir has told you in discrete mathematics big O notation. So you know already. Still I will repeat. Okay. So each such instruction takes constant amount of time. We will assume that this
Sir, could you just repeat what control means, sir? I couldn't really get that.
control means, you see the branch. You know na, branch. You branch go to level you have used, I
Okay,
think. So these are
okay,
the,
okay,
so this type of statement takes how much time? Constant amount of time.
okay,
Similarly, subroutine call means function call. Subroutine call means function call. You are calling a function, suppose fun a comma b with parameter. So these also takes a time when you are calling through this main function. Okay, within main you have written. Now, whenever this function is called, some amount of time will be taken. So how much time it will take? That is constant amount of time. Okay. So the RAM model contains instruction commonly found in real computers. This and this takes constant amount of time. And the data type in the RAM models are integer and floating. Okay, these two types of mainly we'll use. And please remember, in RAM model we do not attempt to model the memory hierarchy that is common in our contemporary computer. What do you mean by memory hierarchy? The secondary storage, primary storage. Okay, so secondary memory, primary memory, or cache memory. No, not like that. Only one memory cells are there. Okay, and that is this is the in RAM model. We will assume that this is infinite. This any program can be loaded. Don't worry about the space. Don't worry about the space. In RAM model, any program, any memory, any program can be loaded here. Whatever be the size of this. Don't worry about this. Actually, this is not in reality. We assume that there exists such a machine, and these are the instructions that can be executed on the RAM model, and how much time it takes. We go up constant time. Okay. And what do you mean by load store? Suppose just you are writing, that means a equal to b assignment. The value of b is assigned to a. So this takes how much time? B go up one constant amount of time. So go to x like this. Go to x. So and x is another level, So how much time it takes? B go up one. Similarly, add means say a equal to b plus c or a equal to b minus c. All these instructions takes, suppose a equal to suppose c by 2. This is the ceiling function. All these instructions take constant amount of time. Multiplication also takes constant amount of time. All this we are assuming this can be done using constant amount of time. These are the assumptions. Now, what is the worst case, best case, and average case? Just a minute. Tomorrow I will not take class. There will be a convocation. So for means algorithm, there will be no class. But for the others, I do not know. So just that's for that I will take another just 10 minutes more. What is the worst case complexity? What do you mean by worst case complexity? Worst case complexity of an algorithm is the function defined by maximum number of steps. Maximum number of steps taken on any instance of size n. That is called worst case complexity. Best case means the minimum number of steps taken on any instance of size n. For example, if you have to search an element x in an array of size n. So what will be the worst case complexity?
O of n.
Big O of n. When it occurs? Means if I get the element at the last
Element here.
I am sequentially searching one by one. Okay. And what is the best case? Means if I am searching the first element and the first element is the big O of 1. So best case, worst case. But we should take care about the worst case. We will expect that best case will not occur. Okay. And the average case. Average case means most you every time you execute the algorithm with different key size, key value. So how much? So what will be the order of time complexity to search that element on an average? So it is the function defined in average number of steps taken on any input size. So these are the definition of worst case, best case, and average case complexity. So you know already the insertion sort. So this is the insertion sort algorithm. Here we assume that the ith line is this is the line number. Basically, this is the line number. These are the line numbers. So each execution of the ith line takes ci. This means c1, c2, c3, c4. Okay. Where ci is a constant. It's some constant. It may be 5 units, 6 units, whatever it may be, but constant. And the length of the array A is denoted by length A, which is n. So here you tell me that in this case, how many times this loop is these statements one is executed? Can you tell me? First line is executed for how many times?
First line is executed n times, sir.
Okay, all of you agree?
n minus 2.
n minus 2.
N minus 2. No. J becomes 2. J then 3. J equal to 4. Now J becomes length of A. N. So how many times?
N minus 1.
Now I am asking to the who means I don't know the name. A somebody told N. Tell me why you are saying.
Sir, I didn't see the 2 to n, sir. Sir, it will be 2 to n. So in that case, it will be n minus 1, sir. I correct myself.
Okay, you are correcting, but actually your answer was correct. I'm saying.
Huh? How?
Yeah. Tell me how. All of you. I am asking to all of you. Why it is so? See, please remember, this statement is executed. I have asked how many times it is executed. It is executed n times. Out of n times, n minus 1 time it is success, and 1 time unsuccess, because j is increased by 1. You check j plus plus, you in C, you know na, that say suppose if you implement using a programming language, then it is like this na, j is 2 to j is less than equal, then j plus plus is there. So you increment then again and you check, oh, its condition becomes false, so it is not executed. Clear? Are you getting? So actually it is n 1 times for unsuccess time. Means when again j is increased, then again it is checked the condition that whether the j is means exceeds the value of length a or not. You know all this. Okay. So that's why it is n times. So n minus 1 times it is success. The loop is executed, but the last time it is not executed. But not success, but it is executed. It checks whether what is the value of j. Is it clear? Hello.
Yes, sir. Yes,
Yes,
sir.
sir.
So and now here you see these statements are executed n minus 1 times. You check it. Okay. C2 is the cost of this, and this is the comment. So its cost is 0. Means it is not actually executed. And you know all these codes, I am not saying. And here tj, what is the tj? Tj is the number of times the while loop, this while loop test in line 5 is executed for that value of I. Okay, tj. So this is executed for j equal to 2 to n. Okay, like this. Now what you have to do, you need to find the time complexity. What you need to do, you have to multiply. See, this statement has cost c1 and it is executed n times. So c1 into n. This key assignment is executed n minus 1 time, and each has cost c2. So the total cost will be c2 into n minus 1. So in this way, you multiply the cost with the times it being executed, and then finally add to find out the total time complexity. So you have what you have to do, that c1 into n, c2 into n minus 1, just you check it, c1 into n, c2 into n minus 1, then 0 into n minus 1, then c4 into n minus 1, then c5 into this sum, c6 into this, because this is again sum, how many times it is executed. So in this way you add all this. Clear? And this, the running time of the algorithm is the sum of the running time for each statement. So the best case, now best case occurs when the given numbers are already ordered. When the given numbers are already ordered. So in that case, you check Tn becomes like this, or the line 6 and 7. You check this. So it will be this linear. This will be the case. K1 is this constant, and K2 is this constant. Okay. And worst case becomes when the numbers are in reverse order. And in this case, you please just see the calculation, okay, for all this. And Tn will be, I am not saying, Tn will be like this. You see, Tn will be here like this for worst case. For best case, it was like this. K1 into some constant linear, and this is quadratic. You see, this is the worst case. And average case, this will be still big. Means you have to take the average j by 2, tj times j by 2, and here you still get n square. So that what is the, in next class I will show in detail, means the time complexity notation, etc. But here you see whatever I am getting time complexity, this tn, this is a function of n. Check it, a function of n. You see, an square plus bn plus c. Here also, this is a function. Here, this is also a function on n. This is the Tn. So time complexity is a function of n. And in next class, we'll see what do we mean by big O, etc. Okay. So please, I will create the for registration in Moodle. So you will register there. Okay. Only for Z sections, and I will upload the lectures also there. Thank you for attending my class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.